Hi guys, I'm going to be solving the question number 5 on drag force classwork. Alright, and over here this time we are going to have a little bit different function. So first we have an object, it's falling freely, so it's going to have mg as a downward force. And then it says there's a resistive force, so that resistive force is going to basically resist the motion, and it's going to go against the movement. So in this case, it's going to go up, and they give you the function as kmv, so you can put this as kmv, or you can put that as drag force. Alright, both will work, so that is going to be basically part A. And in part B, what did they ask for? Write the differential equation that represents Newton's second law for this situation. So again, all you have to do is write down Newton's second law. So all of the forces equals mass times acceleration. So what are the forces acting on the object? You have kmv going up, you have mg going down, and then what do you have? Mass. The only thing that you need to be careful here, your acceleration. So your acceleration will be going down because your mg is greater than your kmv. So that means you're accelerating downward, and since we choose negative, like downward direction as negative, then that is going to be negative A. Alright, so that is why it's going to, like that negative is going to make the difference. Now you can, this is not your final like differential equation, because differential equation requires this acceleration function in terms of v, because v is the common variable for the equation, so you need to convert that to velocity. So in this case you can put this as kmv minus mg minus m. So if you check my math review, calculus review video, you will see how we write this acceleration. So acceleration is basically going backward. So if you're going backward, it's going to be dv minus dt. So if you take the derivative of velocity function with respect to time, that is going to give you acceleration. So this is your differential equation. Alright, so that is going to give you 3 points. And what do they ask for in part C? They're not asking you to solve this differential equation, but what are they asking for? They're asking for terminal velocity. So terminal velocity is a special case. Terminal velocity is the velocity when those two guys are equal, or there is no acceleration in the system. So what does that mean? kmv equals mg. That is going to be the velocity, or that is going to be the situation when you are reaching to your terminal velocity. So your drag force will be equal to your weight. So in this case, what are they asking for? Terminal velocity. So terminal velocity is this guy, and we just change the name of this guy to Vt. And you simply solve this for Vt. And you have m in both sides, then they cancel out, so your Vt will be what? G over K. Alright, so that's so that is this simple basically. Alright, so you don't need to solve for anything. All you need to do is recognize that drag force equals to your weight, and then your velocity in that function this time will be called terminal velocity special, and then vt equals basically, and you just solve it for vt. And in part in part D, they're asking you to solve velocity as a function of time. Now, what are we going to do? We are going to use this part simply. This is our differential equation, and then we will use this differential equation to solve it for like v as a function of time. So I'm not sure if I'm going to have enough space, but let's try. Alright, so I'm going to start with putting negative here first. So I'm going to multiply the entire equation with negative. So I'm not going to deal with this negative over here. So once you multiply everything with negative, that negative will become positive and this will become negative. So I'm going to bring that to the front. So my function will be mg minus k mv equals m dv over dt. Alright, so as you can see, you have m right here, m right here, m right here. So what does that mean? I can simplify all of the m's. So they just give you a special function, or a function that you can actually simplify a little bit more. So my derivative is going to be a little bit shorter, but all the steps will still be the same. You just don't need to include that m anymore. So what do you have? G minus kv equals dv over dt. Again, the way to solve this, you're trying to get all of the v's in one side and the t on the other side. So the only way to have that situation, take all of this function and you replace it with, or switch it with dt. So then what am I going to have? dt will be in one side, and then I'm going to have dv divided by g minus kv. So now all of the v stuff in one side and all of the t stuff in the other side. So now what are we trying to figure out? I am trying to get rid of those derivatives. And to be able to get rid of the derivative, we need to think about the inverse function, which is the integral. So if you take the integral of one side, you need to take the integral of the other side, which you would do anyways because you also have a derivative over here. So taking the integral of both sides is going to help you to get rid of those derivatives. So once you put those integrals, our case is going to be a special case. We are going to have boundaries because we're not talking about a general function. This is going to happen for a certain situation. So my time is starting from 0. Alright, and when time is equal to 0, so those two are basically functions, they are going like working together. So when time is 0, your velocity will be, it is stating there in the question, when t equals 0, your velocity is 0. So your velocity is also starting from 0 meters per second. Then what are we trying to figure out? We are trying to find, so when they're asking for a function like velocity as a function of time, then that means I am not talking about a certain time, like 3, 4, 5 seconds. I'm talking about any time. So that's why to be able to represent that, you just put t. But to not get confused, I just decide to put t prime. So at that t prime time, what's my velocity? I'm going to have the corresponding velocity for that t prime value, and I do not know what that is. It's not a number, it's just any velocity v, so I just say it's v prime. And then how are we going to take the derivative of those functions, integrals of those functions? So if you have boundaries for a basically nothing, if there is no number over there, that is, if you check my calculus review, I had it with a number. So if you don't have any number, then the way that you take the integral of that function is simply you have t to the power 0 right there. So you take integral, you increase the power by 1, which will be t to the power 1, which is t, and you divide it with the new power, which is 1, which is again. So the integral of this function is just t. So this is the integral, but I have boundaries from 0 to t prime. So what will be the way that we are solving this? You basically replace your variable with the upper boundary minus lower boundary. So once you replace this t with t prime, so it will just be t prime minus, now substitute this t with 0, t prime minus 0, so that will give you just t prime. So this section of the integral or the equation is just going to be equal to t prime. So I'll continue from here. So t prime is equal to what? 0 v prime dv over g minus kv. Now we need to figure out what to do on the right side. We are done with the left side, so now we need to solve the integral on the right side. So to be able to solve this, they use a chain rule. So to be able to integrate that function, you need to have a little bit simpler here because this cannot be integrated. So what do? They decide to use another different notation. So they just give this a number or another variable. So they use function u or letter u. I don't know why, but that's just a convention, all right? So they just call this complex function u to make it simpler. So g minus kv. So what is that? Like this equation will become dv over u. But now I need to figure out v in terms of u because you cannot, again, integrate if you have a v in one side and u in the other side. Yes, u is in terms of v, but you cannot solve that without having du. Then what do? They are taking the derivative of this function u with respect to v. And how do we actually represent that? It is represented by du, take the derivative of u function, divided by dv with respect to v. And if you take the derivative of this function, you have a constant right here. Derivative of a constant is 0. Again, you can see it in the calculus review. And what do you have in front of v? You have just negative k. So derivative of that function will just be the number in front of it, so that's going to be negative k. So now what do we have? Du over dv is equal to negative k. Then what can we do? We can substitute, or we can write those two functions in terms of one another. And I'm going to need to replace this dv from there, so I need to find this function in terms of dv. And again, if you would like, you can just switch those two functions. Then what is going to be dv? So your dv will become du divided by negative k. And this negative can be taken to the front, so it's just going to be dv equals negative du over k. So now I have this function g minus kv as u, and I have this dv in terms of du. It's negative du over k. So what I do, again, I'll continue with the blue one. So that's where I left the function. So at this point, what am I going to do? I am going to replace dv with negative du over k, and I'm going to replace g minus kv with u. And let's continue from here. So that's t prime. So remember, we were done with the left side. And now 0, v prime, these are my boundaries. So instead of dv, what am I going to use? I'm going to use negative du over k. So I have replaced this dv with negative du over k. And now I'm going to replace this part. And if you think about it, this is 1 over g minus kv. So I use u for this, then it will become multiplied by 1 over u. Alright, again, that's just separating this as like dv times 1 over g minus kv. That's what I did right there. So I have replaced dv with negative du over k, and then I have replaced this 1 over g minus kv as, or with, 1 over u. Alright, and now I can multiply this function, and then what am I going to get? T prime is equal to 0 to v prime, and then I'm going to take all of the constants, which is negative and k, to the front, negative 1 over k, times, and I'm going to put u's together, du over u. And this is a constant, so that can be taken out of the integral. So t prime equals negative 1 over k integral of 0 to v prime. So I got rid of the constant, so I only have a nice function right now, du over u. So, and at this point you can actually get rid of, or like put this 1 over negative 1 over k to the other side as well. And how can you do this? You basically multiply everything with negative k. Because if you multiply everything with negative k, what's going to happen? This negative 1 over k will be just, k's will disappear, and negative is going to make this positive, so it's just going to get rid of that 1 over k. Then on the left side I'm going to have negative k t prime, and that's going to be equal to 0 to v prime du over u. And now I have a nice function, because du over u is a special function, and integral of 1 over u, or 1 over any function, will just be what? Ln function. So negative k t prime will be equal to ln u. This is my integral, the result of that integral. But once you have taken the integral, if you have boundaries, what should you do? You should include that 0 and v prime. Now what do we have? Ln u. But now, since we got the integration, I can replace and substitute that u with the original number itself, and that is g minus kv. So negative k t prime will be equal to what? Ln g minus kv, and then you're going to go from 0 to v prime. Alright, now what do we substitute which number do we substitute now? So my only variable, g is a constant, k is a constant, so only variable in this function is my v. So I'm going to be substituting this v with the upper boundary and the lower boundary. So now let's do this. Negative k t prime is actually equal to ln g minus k. So I'm going to substitute this v with the upper boundary first, which is v prime. And this is my upper boundary minus, replace the same variable with the lower boundary. So it's going to be ln g minus k times 0 this time. So now, what do you have? You have two ln functions, and you subtract them. So negative k t prime will become what? Ln And if you remember, I had told you if you have two ln functions, let me write it right here as well as a reminder, ln A minus ln B. How do you write this one down? Ln A divided by B. Alright, that is a function. I mean, that's the property of ln function. So you have ln something minus ln another thing. So what do? We will just write this as g minus kv prime. This is the inside of ln function in the first part, minus g minus k times 0, which we'll just get rid of this part. So g minus kv prime divided by g. So now I have this function, negative k t prime equals ln g minus kv prime over g. And now I need to get rid of this ln function, and to be able to get rid of ln function, again, we're going to use another property of logarithmic functions. To be able to get rid of ln, you need to take this as a power of e, because mathematically, in math, what they tell is, alright, let me write this math part here again. E to the power ln x is going to give you x. So what do I need? I need this part. So this is ln, technically x. So if you would like to get this x part, you need to write this ln x as an power for e. And if you're doing this as e, so one easy way to write this, like I'll just put this too large like this, alright? So you basically put the e as a base, and then you take the numbers as a power now. So now left side becomes what? Let's continue as regular. Left side just becomes e to the power negative k t prime. And what do we have on the right side? E to the power ln. They cancel each other out already. And I'm going to have g minus k v prime divided by g. So now we are I'm tired. All right, v prime, we will try to solve this guy for v prime, and I have k in front of it. I have g, extra g right there, and I have a divisions. First, I need to get rid of this g, so multiply everything with g, then your function is going to become g e to the power negative k t prime. And then I get rid of this g, and that is equal to g minus k v prime. And now I have this extra g right there, so subtract g from everything, like from both sides. So g e to the power negative t k t prime minus g equals negative k v prime. And now you can multiply everything with negative to get rid of this negative. Then what am I going to get? G minus g, because that g will become positive, so it will become to the front, and this will become negative. E to the power negative k t prime equals k v prime. And the last step for us to find v prime is dividing everything with k. So your v prime value will become what? G minus g times e to the power k t prime divided by k. So that is your velocity function with respect to time. I know it's long, but this is the same solution again and again, alright? So all you need to do is basically try to solve this 1 time, 2 times, 3 times, and after a while you're going to get familiar with the steps. Alright, so since this is the first time that you are introduced, it seems so complicated, Yes, it's not straightforward, um, but as you practice more and more, you will get familiar with the steps. All right, now in the last part on the axis, they ask you to draw a terminal velocity function. So what's going to happen? Your terminal velocity as a function of time. So that is v, this is t. So they want you to specify this vt, and remember we found vt as g over k. So what's going to happen? First, you are starting with a 0 velocity when time is equal to 0. And first, you are speeding up. But as you speed up, what's happening? Your terminal velocity, your drag force is also increasing. So you are basically going to have a curve, decreasing velocity curve. All right, and then you are going to reach to that constant Vt right there. So you are going to have this curve going like this. All right, so that's basically how you solve question number 5 on your classwork.